So, hi, this is Brad Dyke, just reaching out to say hi. Today we're going to do a hardware video. And it's kind of a build on from a video I did recently about taking your home ideas, your IT labs, and growing them out into something more. How do you get beyond the dogma of today's IT technologies forums of networking or GPUing or processing or service running and so on? And in that discussion, I made a whole variety of options to say, hey, think outside the box. The box is pretty cool and it's really neat. And, you get really interesting responses like somebody wants to take a Raspberry Pi and put it into an electrical receptacle box. Well, why not? What the heck? That makes perfect sense. But one of the carryovers at which they had in that was, if I want to do a home server, what would it take? What is the 1, 2, 3s of Home Server 101 to get me to that place I want to be? Well, to start with, I would say first, know what you want to do. That's the first thing. Now, some of these guys and gals said, well, I want to be able to hook up sensors and things like that through a USB analog to digital converter board and make it as neat and as capable as what we call home automation. And home automation is where your server, your home server, will control things in your house for you and do the things you want. And in the process of doing that, provide additional resources like security or thermal imaging or things like that. But as complex as that sounds, the reality of the fact is, what if I just want a basic home server? What if I wanted to do just a website? What if I wanted to do a website and store my photos? What if I did this or I did that as an added benefit to get me where I want to be? Let's say media streaming, let's say some sub services that you want to kind of keep in house. Do you want to do SMTP email services or a proxy boxing or something like that? The first thing I say is write it down on a piece of paper. First thing I always say. Take the time, if it's really worthwhile, write it down on paper, because that is going to tell you exactly what you need. Secondly, you need to know what technical skill set you have. In other words, are you a newbie coming in? You're a 1 out of a 10? Or are you a 9.5 kick butt, high-end, 30-year veteran, whatever you want to call yourself, and you can pretty much do anything you set your mind to? Well, the reality of the fact is, if you do that, you'll get a better success ratio than just arbitrarily buying something. Now, there are two aspects to this. One, your knowledge and what you can do means you want to get a certain type of platform like ClearOS or Proxmox or TrueNAS or other variations, or even just Ubuntu server with applications loaded on it to provide your needs for it, depending on how capable you are. Now, I'm not kidding you. This can be really easy. So pay attention to this. Be honest to yourself and say, I really can't do this very well. You gotta hand walk me through it. And there are operating systems for home servers that will do just that. So don't worry about that too much. The second thing is the hardware. You can't have a huge data streaming platform for all your media streaming and use a simple Raspberry Pi, right? It's kind of underpowered. So you got to make sure that you take the time and realize what is the best solution. For 1 to 2 to 3 people, you could get away with using something like this as your hardware. It's basically it's an i7. It has 32 gigs of RAM. It has lots of USB 3.0 ports on it, which is what you need for streaming. And it will give you some basic functionality. It can cover a lot of things. It can provide security. It can provide monitoring. It can do limited streaming. This is a 1 to 5 user level equivalency because it has all the requirements up to 5 users to do what you want to do. But it is small, right? If you had a single user out there and you're in a very small footprint, then yes, I do recommend a Raspberry Pi. It's very small, 4 to 8 gigs. It's got a 1.7 quad. It's got all the variances on it, Wi-Fi and so on, 1 gig capacity. You could do some very limited streaming by using a disk array that would be connected. And let me give you an example of what I mean by the disconnection process. So if you had a Raspberry Pi, like you see right down here, or a series of them linked together to do the workload, you can then bind them to an external disk array that uses 3.0 bandwidths, and you would have your disk capacity here, and that would give you a very basic one-user kind of home media footprint. But if you had a basic need for more, you could go up here, like you see these Series 70s up here, these 740s, and one or two of them could be your primary with a failover. That's basically the same copy. That's just one copy of another acting as primary versus alternate as a backup. And they can even power share to stream data for multiple disk arrays that are USB 3.0 connected to those devices. And that allows you to be able to do 1 to 5 people. But the reality of the fact is, what if you're a little bit more savvy, right? You can buy these pretty easily. You can get these super cheap. These are about $100 roughly. This is basically about $100, and the discs inside are what you spend for. Or you can go to the Raspberry $80 footprint, which is really turns out to be about $150 for a Raspberry Pi node, and you have multiple nodes here, and that would be able to provide you a basic environment. Now, this is a Proxmox home server version deployment. These are all in one Proxmox cluster, and they have their disk capacity. So this is scaled for 25, 30 people, and it's quite capable of doing quite a bit for you. That gives you an example. Now, Proxmox is one of those operating systems that are decently rated, about I think roughly a 3 or a 4 on the top 10 list. Ubuntu is the highest one with the number 1 rating. TrueNAS, which is what I use also can do it. And down here is TrueNAS. I have a Dell 720 here. It's a dual processor high Xeon environment, boatloads of capacity, and it has a disk array down here below it, as you can see here. And this disk array is everything I need for functionality. But let's say, hey, I found a chassis that's even better than this, and that chassis would be this guy, something like this Series 820. Now, this is a nice chassis because it has up to quad power, in other words, 4 CPUs, but runs great on 2. Boatloads of RAM capacity, and on top of that, I've got a whole pile of disk capacity as well, all in a single box. That's it. So, also, I could attach more disk storage to the box over time if I really needed to. So the hardware is really driven on what you can do. So we've talked about the basics. What do I want to do with my home server? The secondary part, the hardware. We also talked about your skill set. How competent are you able to set up a home server? And my suggestion there is, on the hardware side, is driven by the first 2 prerequisites. Specifically, what do you want to do? What services do you want in your home? What technical skill set do you have? Then you decide, do I go simple? Or do I want to go something more capable? All of these options work. They have their own levels of performance. Most of the smaller footprints will be using USB 3.0 bandwidth. So that's your equator right there to tell you how fast you can stream stuff and how many people can stream things at once, and so on and so on. You also have the ability of compartmentalization and low power consumption. That's the benefit of using something that works in a 90 watt or below value. So that's cool. But there are some disadvantages. When you're dealing with microarchitecture deployments or laptops, as another example, your internal bus processes are clock divided. In other words, they can use 32 pathways and clock divide them and make them 64. Or take a 64-bit pathway and clock it by 2 and make it 128. It has a wait state on it, so there's a little bit of a performance impact because of that. reduced pipe that you're sending your data through. Now, if you went through and got yourself an older chassis, a Xeon chassis, for instance, a server, and they're super cheap. You can get them between $50 to $150. Great deals, awesome, very capable. Even the 5200 series Xeons can do a wonderful job on handling workloads, but they consume a little bit more power. And they can be a little noisy if you don't know how to cycle down the fans and run them in a what we call a pseudo hybrid state, because you're never going to saturate two Xeons. The nice thing about the two Xeon platforms is you have redundancy without having to buy another box, because it's an SMP based motherboard or a symmetric multiprocessing environment where if one processor failed, you'd still keep running. But the good news is with that is old servers back in the day could do a lot of memory, decent processing on the processors, and they had slots for drives. So you could get away for quite a while for a home station with a 1U Xeon based platform that would have either one row of 4 disks or 8 disks, depending on the model tier. And that's a lot of capacity right there. As a matter of fact, the HP 380 and 385s, any of the gens, I'd say Gen 7s up. Excellent chassis for this kind of stuff. Just don't have it in the room when you're watching media, because you're going to compete with the sound that it makes. But, the HP servers, nothing wrong with those. The Dells, the Super Micro chassis, they can all do that functionality. Now this is advanced hardware that's super cheap, and if you take a little time to learn it, on a scale of 1 to 10 technical skill set, a 2 could do this and become a 4 pretty easily. But the other part of it is the ability of compartmentalization. In other words, growth. Because if you're a streamer, you're going to need to plan for more discs over time. So with that, that's why I'd offered you guys to say, hey, look at a 4U that has everything in it and plenty of disk space, lots of availability, but scaled down the processor so it doesn't run hot. And it will run cool, which means it won't blow the fans high, high blowing power and so on. But you can fill it full of RAM, and you can do quite a bit with it, like I showed you on that 820 down there on the floor. And it gives you quite an ability, honestly. It's really impressive how it functions and works. I think you'll get a kick out of that. Now, for those 7, 8, 9, and self-imposing 10 level techs that exist, you're going to want to go a step beyond. You're going to probably want to go where you have what's called a hybrid chassis, a Telcom equivalency chassis, which will have something like a pfSense sub-tier board in it that has NIC cards, fiber, those kind of things up in the upper part of the chassis, and then you consolidate in a micro model chassis that would be basically like a foot by foot by foot square box, right? It's kind of small. It can handle 8 drives. It's got a nice micro ATX motherboard in it. And it's got the right balance of CPU power with RAM capacity. You don't need GPUs in it. There's no need for that. There's just no functionality for that for home servers, unless you're crunching numbers. And then up at the top of it would be a small micro Ono board or a Pi board with a PCI bridge card that would provide you a boatload of connections, and you'd create yourself a little cube, a home server cube of sorts. Now, back in the early 2000s, these boxes that I just described to you existed. You could buy them. They were also referred to as home cubes or office cubes and so on. And they were literally just boxes that you could put on a shelf, run a connection to it from your ISDN line or from your modem. Yeah, believe it or not, that's kind of showing some of the age. And it had this little RJ45 10100 port on it. And it did pretty good. It did web services, it did SMTP services, it did your account control management accounts services. The introduction of well, the continuation, but not quite ADS, or Active Directory or LDAP. And then they had capacities and shares and things for storing data. And then these boxes kind of faded away over time. But I can see all the advanced tier technicians trying to figure out, well, how can I make this work? How can I use my 3D printer and make a chassis front end that's going to give me everything I want, so I can have it all in one shell box? That would be the mission statement. And you would have two of them, one on each end of the house, one up high, one low, or one at the back, or one at the front. And if something ever happened to one of them, the other one would kick in and take over and keep driving. It's called high availability failover. Complexity is in that equation, but it does offer more power because you can combine them in what we call adaptive load balancing, and they can balance the workloads between the two nodes. And if something did happen to one of them, because these boxes have a single power supply in them, they're not dual redundant, and the power supply just blows, right? No problem. All your data, everything is still safe. The other node is, replicated whatever was on the first node, and you can keep going. It's that potentially capable. So, what does that inevitably mean, hardware-wise, and getting off the ground with software? It's very easy. Keep it simple, stupid. Start with the basics. Whatever level you consider yourself at from 1 to 10, be humble. Go down a level. That's probably where you really are. Start there. Once you're done and you finished it and you get a good feeling for it and you're really ready to optimize, let's say you're going to use Clear OS, or you want to use TrueNAS with plug-in modules that you add that will provide you those home services that you want, and you get the basics under your belt, then you can say, hey, I'm going to wipe it all clean. I'm going to start over and I'm going to do it again. But this time I'm going to put it on a bigger piece of hardware that's going to give me everything I need because I learned my lessons. That's why we call them lessons learned. Just keep it simple. Have some fun with it. Now, for those who ask the question, well, how do I start my first home server that I can use what's called a digital analog USB input for sensors I would like to add to my home server? Now, again, what does that mean? Okay, that means you might want to put an intruder alert system into your home so that if your doors are basically opened or windows are broken into or something like that, your alert system will say, hey, alert, call 911, somebody's breaking into the house. It's that simple. They have basically what's called a gathering point, and that gathering point will have a piece of software which you can download and put into that, and that will monitor that system, and it will usually require a USB connection if it's a certain level, or it could be network wireless as well. Also works as well. There are other kinds of sensors that exist out there. They can be cameras that are analog, but they go through a conversion process through your daughter board and will come out, from an analog BNC. As you can see, this is a BNC analog hookup. This is a basic non-digital camera, but you can feed it right into a DVR through a converter board, and you can set up cameras, as many as you want. There's no limitation. You just gotta have the disk space for it. You can also go after thermal registrations, like for instance, if you wanted to make sure your refrigerators never lost power because you have thousands of dollars of meat in them, you can work and put thermal sensors inside refrigerators, and they'll give you a heads up if the temperature gets below at a certain point, or a loss of power, or something like that. Another great tool is the digital plug-in interface that actually can plug into your home power system, and it'll tell you how much you're consuming on your home environment. Brings in the telemetry digitally into your home server, and you'll know who's burning too much energy for what reason. It's usually the guy with the IT lab in the garage. But you can also get more complicated. Like I said, a lot of homes, I think roughly 2,500 homes were lost in wooded areas that had to deal with forest fires. And some of the people got smart and they realized if I had a thermal sensor or a chain of thermal sensors in what's called an analog sync loop around the property, I could sense the change in temperature, and I could tell, the owner that, hey, it's getting hot, you need to get out. Or you can put in what's called an auto sprinkler system in that mists water all over the house, all over the property, to create what's called a hyperthermic style water vapor barrier between your home and those forest fires to try to minimize the damage. You can do quite a bit, ladies and gentlemen, because all it is basically you have a bridge daughter interface card, something like this, that will have terminal sets for analog connections, and it's just 2 wires or 3 wires at max. And those terminal boards will have, you can get them for 8, 12, 24, 48 connections. And then they come in on data paths. And then you link the data path of the voltage to an answer, 0 or 1. That's it. And then you say, hey, on data path here, when you have a 0, go to this application, put up this alert. If you got a 1, don't do anything. And rinse and repeat over and over and over. It can get more complicated, more interesting as you advance your skills, but the sky's the limit. You can make your home your own spaceship. That was what I used in my previous video. I think it's pretty accurate, because imagine that you can do something really special with your home, provide you more services, provide you better security, visibility, knowledge of what's going on around you, and you did it for fun on your own home-built home server. So with that, if I had to give a recommendation, I would say the RTXL Dell chassis, which is a blade chassis. It can hold 30 hard drives and 4 blade servers. So that's for the diehards. Those are the guys and gals who think they're a 9 or a 10. This is not an easy piece of hardware, and it has a lot of power in it, but if you put 1 to 2 blades in it, that's all you need to be power savvy. But to put 30 hard drives into it, and it's a Dell chassis, it's a blade, to be specific, it is a Dell blade chassis with its own internal disk array built into it, and it's a 4U fit, which is impressive. The 820s aren't bad either. They are really they can do everything you want to do and then some. Lots of scalability and growth, but that would be a 7 to a 9. For those who are from a 3 to a 6, try just a simple chassis server. Don't get it with just 2 hard drives. That's a mistake. You want to at least get 4, 8, 12 is optimal. And that it also be about 8, no older than 8 years. That would be probably pragmatic. Anything older would require some additional technical savviness. And then that leaves us to the 1, 2, and 3s. And the 1, 2, and 3s are pretty easy. You can just get a PC tower, a little micro format, even, just a small form factor PC that was once in your office, and it did your basic 1, 2, 3s. It will do quite a bit for you, for, like I said, 1 to 3 users. So with that being said, I challenge you guys to go out there and first be humble and be realistic of what you really can do, because then you'll have fun, because your knowledge will be applicable. If you go the other direction, then it's not going to be so applicable, and that's not going to be fun. But for now, I just wanted to say that I hope you guys enjoy this. I'm trying to get people more inspired to think outside the box more, because I've seen some pretty weird things come from some of you out there that have given me feedback. Like, one person recommended a double set loop on adaptive load balancing on 2 servers on a 12-port switch. That was a 10 gig switch, so he could get, about 42 gigabit bandwidths, and he couldn't mark it correctly. I said, how the heck did you do that? That's impressive. You shouldn't have been able to do it, but that's cool that you did it. And all they did was use ALB, and they kept it on a single switch, and they did it, and it was impressive. Their backup jobs went by like lightning. It was really impressive. And so on and so on. You guys just, I do this to say have fun. The more you learn how to work to play is the best way to be paid to play. And you'll make some real income once you really get into it. So this is Brad Dyke signing off on the hardware video for this week. God bless, and you guys have a great week. Take care.